Engineering and architecture pushed boundaries and shattered records. Innovation met sustainability, and our cities became hubs of creativity and technology. A journey that chronicles the remarkable history of engineering and construction, from the dawn of civilization to the modern world. This is the story of humanity's ceaseless quest to shape the world around us. As time marched on, so did our knowledge. The Industrial Revolution brought forth a new era of construction that would shape the modern world society as symbol of progress. But this story is far from over. Today, we stand on a new age, a digital age, where smart materials, artificial intelligence, and cutting-edge technologies promise to redefine our world. Welcome to Building the Future, 3D printing and construction. Today, we'll delve into the remarkable world of 3D printing and construction, where innovation meets infrastructure and where construction takes a giant leap into the digital age. In this presentation, we'll embark on an incredible journey. We'll explore the history, the materials, the process, and the chemistry behind 3D printing and construction. Together, we'll uncover the promise of efficiency, sustainability, and innovation. To give you a little idea on what 3D printing and construction looks like, let's watch this. In an industry traditionally bound by bricks, 3D printing is revolutionizing the way we build. It's not about building the structure, it's about redefining the essence of construction. 3D printing has been around for a while now, but it's only recently impacted the construction industry. First, let me discuss the history and the benefits of 3D printing in construction. The year 2000 seems like a short while ago. But the first development made in 3D printing of concrete date back 23 years. After successfully printing ceramics, the Contour Crafting Project, University of Southern California, aimed for using concrete for printing larger concrete construction elements. This Dutch team accepted the challenge and started experimenting. 2005 marks the year that Weber Baymex realized the first manually 3D printed wall in one continuous process. It was 3 meters wide and over 2 meters high, and took 2.5 hours to produce. The wall was built using a cart with its wheels and rails that move left, right, and back. The cart carried a nozzle that distributed the mortar. In 2015, Theo Salet, professor at the Technical University of Eindhoven, initiated the consortium 3DCP. It marked the introduction of untold 3D printed technology to the previous manual process. Things started moving fast from there. The combined knowledge of Bang, Weber Baymex, and TU Eindhoven led to the development of ceramic computer models, optimized mortar, mixes, and printing robots. Shortly after 2017, this resulted in the first rolled 3D printed concrete bridge. This 8-meter-long engineering feat was placed in Hamer, the Netherlands, and no more than a year later, the equally newsworthy Milestones Housing Project was revealed. A series of 3D printed house in Eindhoven. With this, a whole realm of new possibilities opened for the 3D printing market. Another big milestone followed in 2019, when BAM and Weber Baymex opened the first industrial and commercial 3D concrete printing facility. Its 2 printing robots are now operational and working on projects on a regular basis. Currently, the factory is working on another first-in-the-world project, the longest 3D printed concrete bridge in the world. It stretches up to unprecedented 29 meters. This project was commissioned by the Dutch city of Nijmegen and designed by a renowned designer, Michael van der Kees. It consists of separately printed elements which will be assembled on site. A daring and complex project which involves sustained experimenting and testing. 3D printing concrete is not just beneficial for big, audacious projects. For normal routine jobs, this technology can save sustained amounts of time, cost, and waste. Like the formwork of the concrete elements from the train station of Drayton Merit 6. This project resulted in an 80% saving on the on-site labor and 6% saving on the process time on-site at no additional cost because concrete is only printed where it's needed for the construction. We're able to vastly reduce the amount of mortar needed. And since there are no more need to make models or cast, we can minimize waste. Now maybe you're wondering, who's the man behind all of this? Well, it's not attributed to a single person. 3D printing construction has been a collaborative effort involving many individuals, companies, and researchers institute over the years. Now let's move to the chemistry behind 3D printing and construction. The chemistry behind 3D printing construction is primarily related to the materials used, the processes involved, and the chemical reaction that takes place during and after printing. Here's a more detailed explanation of the chemistry behind 3D printing and construction. The printing materials. Concrete, the most common material used in construction. 3D printing and special concrete mix. This concrete mix typically includes Portland cement, aggregates, water, and additives. The chemical reaction that occur in concrete during and after printing are crucial for its strength and durability. Hydration is a key element process in concrete, where water reacts with concrete, cement, to form calcium silicate hydrates, which harden and provide strength to the material. Polymer binders. In some construction 3D printing processes, polymer binders are used. These binders can be made of various polymer or resins. The chemistry here relates to the curing and solidification of these polymer materials. This often involves photopolymerization or other chemical reaction initiated by UV light or heat. Extrusion or deposition process. In many construction 3D printers, the material is extruded layer by layer, similar to how traditionally fused deposition modeling or FDM 3D printer works. The chemistry here involves the extrusion process itself, which relies on temperature control to maintain the material's appropriately viscosity. Setting and curing. In concrete-based 3D printing, the setting and curing of the material are vital processes. Setting occurs as cement hydrates and forms chemical bonds. The curing process involves maintaining the proper environmental conditions, such as temperature and humidity, to facilitate the complete hydration and hardening the concrete. Admixtures. Various chemical admixtures are added to construction materials to modify their properties. Superplasticizers, for example, improve the workability of the concrete mix. Accelerators and retards are used to control the setting, time, and air retaining agents to help create tiny air bubbles in the concrete to enhance its freeze-dry resistance. The chemistry of this admixture are influence the material's performance. Post-processing. After 3D printing, some structures may undergo post-processing, such as chemical treatments or coating to improve surface finish, waterproofing, or other desired properties. Sustainability aspects. Sustainable chemistries plays a role in 3D printing for construction, with a focus on reducing the environmental impact. This includes the use of eco-friendly materials such as low-carbon cements or recycled aggregates, and exploring ways to reduce waste in the construction process. Quality control. Chemical analysis is crucial for quality control. Material composition, mechanical properties, and durability testing are performed to ensure the 3D printed construction meet the required standards and specifications.
Now, let's move to the interesting part of this topic. The process behind 3D printing in construction. When the engineers arrive on site, they typically work on a slab or a ribbon footing. And what they do is they set the printer up around where the house is going to go. they typically have around 5 or 6 pieces of equipment, and that is the printer, and they also have a control panel to operate and monitor the printing settings. Then, on the material side, we have a silo which holds the dry material, but directly below that, we have a mixing system and pumping system. The water is added in that process and pumped through a hose, which then feeds the printer material. This process isn't very different than a typically desktop 3D printer. What you do is you start your design stage and you create a CAD file that basically tells the machine where to go and how fast to do it and how much material to let out that specific spot. And so the program is the center line of where the nozzle is, and the printer will follow the line throughout the whole process. The two rails will provide your outer bounds for your wall, and so that in the middle portion is where you can run electrical plumbing. However, it's more of a hands-on system where we construct all the walls and we guide the GCs through installing the doors, windows, HVAC, and plumbing systems. What happens is it kind of splits the house into two walls, left of the door and the right of the door. And what we'll do is we'll do that wall until it lifts up and go to the other side of the door and complete the other wall section. And then once you're on top of the door, what we do is we add a manual support. And so that what we do is we add a steel rental that stretches across the window or door. And then the printer then continues printing directly over the top of the system. Each house consists of around 150 layers, and each layer is approximately 3/4 of an inch thick. And so that makes a standard 9-foot wall based on our current mix design. Each layer takes about 5 to 10 minutes before we add another layer on top, so that it's like the layer set time until it's hard enough to be able to be added, and then we try to hold off for around 2 weeks before any large load bearing weight, such as a roof system, be added and a concrete reaches the max strength of 28 days. Nozzle design is really customizable, especially in the 3D construction industry. There's the squared off nozzle where it has a flat aesthetic, and then there's the rounder nozzle that leaves a more of a bead look. They have the same properties as far as structural design, it's more on a static finish. The process is the way it's done, very similar to a bricklaying system, where would you go around and do one layer of bricks, and then once the layer is finished, you go to the next one. It's very similar in that process, however, the building material and the labor-intensive portion of that is obviously different.
We've just scratched the surface of the vast potential of 3D printing and construction. What you have seen today is the present, but the future promises even more incredible feats of innovation and sustainability. Thank you for joining us on this incredible journey into the future of construction. Stay tuned for more exciting development in the world of 3D printing and construction, where the possibilities are endless and the future is bright. I'm J.M. Perazambalos. Peace out.